Everybody, welcome back. This is Grockit OGTV GMAT edition, where we go through the official guide to the test, question by question, cover to cover. My name is Jim Jacobson. I will be your tutor and teacher today. When we left off last time, we were on page 153. Let's get that over here. Page 153, question number 7. I'm going to change that brush size a little bit. There. Okay, so, and then this one we had 67, 128, 191, 197, and 260. So the sum of prime numbers that are greater than 60 but less than 70 is. So for this one, we really don't have a lot of predicting that we can do. There's only this question of what the prime numbers are greater than 60 but less than 70. Remember, prime numbers are numbers that only have two factors, themselves and 1. So, if x is a prime number, it has as its factors 1 and that number itself. So we need to figure out what the prime numbers are between 61 and 70, and keep in mind that an odd number is not necessarily a prime number, nor are all prime numbers odd. 2 is an even prime number. That's important to remember for the GMAT, but 2 is way less than 61. So the numbers that we have between 61 and 70 should have left more room. 69. So of these, of course, 61 is prime. The only two factors are itself and 1. We can cross off all the even numbers because those will have 2 as one of the factors. 65 is divisible by 5, and any number whose digits themselves will add up to a multiple of 3 are themselves divisible by 3. So 6 plus 3 is 9. That means we could divide this by 3, which means it doesn't have only two factors. 69 likewise, 6 is divisible by 3, as is 9. So that leaves us with only 61 and 67 as the prime numbers greater than 60 but less than 70. We just need to add the two together. 61 plus 67 equals 128. Do note that, and so that's choice B here. Do note that we did actually have a trap answer here. This one's a trap. Makes us unhappy. This one perhaps is thinking that people would miss 61 or assume that, I don't know. Actually, I'm not exactly sure. I guess they're just assuming carelessness, that greater than 60, maybe someone starts at 62. In any case, one trap answer is one of the answers from partway through the answer choices, but really there are only the two prime numbers. Choice B is the correct one. So number 8, still on page 153. Okay, a rainstorm increased the amount of water stored in State J reservoirs from 124 billion gallons to 138 billion gallons. If the storm increased the amount of water in the reservoirs to 82% of total capacity, approximately how many billion gallons of water were the reservoirs short of total capacity prior to the storm? One of the big tasks on the GMAT is always converting words into math. In this particular case, we know that the storm increased the water to 82% of total capacity. So that's 82% of, we'll just call it C for capacity. And we know that, and then this equals the number after the storm, 138. We could, I suppose, put all the zeros to make this into the billions. The math is just going to be easier if we leave it as 138. So we convert this into more straightforward algebra. This comes out to be 0.82c equals 138. Because here we're trying to figure out what the total capacity is. We need to figure that out in order to solve the rest of the problem. So then C is going to equal 138 divided by 0.82, and you can do this a couple different ways. I usually, when I see these things, the numerator and the denominator are both even numbers, and I can reduce it. That is going to be the same thing as 69 over 0.41. Smaller numbers make me happier. Then it's just a matter of doing the actual division. 41 goes into 69, and we're actually going to have to move the decimal point over 2 because this was 0.41. So it ends up being So, we don't really have to go past this point on this question because none of the answers actually go into the decimal values, and all of them are separated by at least 5. So the decimal point isn't going to make a difference. The answer to this one actually has you estimate the value, but then you still have to divide the numerator by the denominator, which ends up giving you, you still have to do the long division anyway. I'm not sure that estimation actually saves you any time on this one, but estimation is a good skill. There are other problems where it comes in handy. So we know that full capacity is something between 168 and 169. So 168, we need to figure out how many billion gallons of water the reservoirs were short of total capacity prior to the storm, which means we need to use that first number, the 124, not the second number, 138. So minus 124 equals 44, which is choice E. Do note that if you weren't careful, of course you were careful and I was careful, but less careful test takers might have chosen the wrong number. 168 minus the other number, the post-storm value, ends up with 30 billion gallons. So that makes a trap answer here, which is how trap answers are often formed. If you're given x and y and have to solve for y, one of the trap answers will be x in case you solved for that inadvertently and didn't convert. Anyway, choice E is the correct one, 44 billion gallons. Page 153, question 9. So we have -1, -1/2, 0, 1/2, and 1. So on the graph above, when x equals 1/2, y equals 2, and when x equals 1, y equals 1. The graph is symmetric with respect to the vertical line at x equals 2, according to the graph when x equals 3, y equals what? Can redo that graph. Sorry, actually I'm just going to undo that one. That's not a very good y-axis or x-axis. Better. Still not thrilling. But on the real GMAT, the only one who needs to understand your drawings is you, and the unit markings are actually as important as the quality of the lines. So it goes here like that, something like that. Anyway, it's symmetric along the line x equals 2. So, and symmetric is just, it's a word with a Greek root. There's a few of those in math. It just means measured together. So basically when something is symmetric with respect to a vertical line, it's the same on both sides. The graph is exactly the same, so you can find the mirror image of any given point on one half of the image on the other side. So we know that x equals 1, y equals 1, so these are those. Well, sorry, that's this one. And then so basically the other one on the opposite side where x equals 3 will be the mirror image of the same one that, so when it's 1 unit away from its point of symmetricity, the distance that it is when it's 1 unit in this direction, vertically here, remember it was 1, 1. It's going to be the same distance vertically when we go the same distance this way. So it'll be still a distance of 1 when x equals 3. So the coordinate here is 3, 1, which leaves us with answer choice E, y equals 1. I'm not exactly sure where these wrong answer choice comes from. None of them are obvious trap answers. At least nothing that comes to mind for me. I guess they're just counting on you not being familiar with Cartesian coordinates or the coordinate plane. So anyway, symmetrical along this point, it's going to be that guy there. On to the next one. Question number 10. So we have 0, 50, 450, 495, and 500. So when 1/10% of 5,000 is subtracted from 1/10 of 5,000, the difference is what? This is another one of these converting words into math. And of course, one of the things you have to be careful of, it doesn't turn out to be an issue on this one, but one of the things you have to be careful of is the way that they word these things. So when x is subtracted from y, when x is subtracted from y, that's really saying y minus x. X is being subtracted from y. So we just have to make sure we get these things in the right order. So the first number that we need to mention, so because we're subtracting a smaller number from a larger number, 0.1% is a smaller amount than just 1/10 of something, which is 10%, right? So when you subtract the smaller number from the bigger number goes first, lest you get a negative number. None of the answers are negative, so clearly we need this in the format y minus x. So the second number that we have is 1/10 of 5,000. And you can express it as a fraction or as a decimal. That's up to you. Whatever you're most comfortable with. In this particular case, I don't think it's going to matter. So 1/10 of 5,000, and we're subtracting from that the first number mentioned in the problem, 0.1% of 5,000. So, and you don't have to do it this way. You could do it as a decimal. This makes me happier. A lot of times, even though you haven't done fractions probably since grade school for a lot of your real life day-to-day stuff, there are actually a lot of instances, especially on the GMAT, but in real life, where actually they make computations easier. They're a little bit more of a visual. Oh, sorry, that's just 100. 1/10 of 1%. So this is the percent here. 1 out of 100. So 1/10 of 1% of 5,000. So 1/10 of 5,000, we just move the decimal place over 1. So it's 500. That's easy. The second one, 1/10 of 1/100th equals 1,000th. 1,000th. Times 5,000, which is the same thing as 5,000 over 1. So we can do a lot of canceling on this, on the right-hand side of this, because the thousands all cancel out. So really it just ends up being 500 minus 5, which equals 495. Choice D is correct. Do note we have the trap answer here. It's not an awesome trap, and of course we didn't fall for it, but this one assumes that maybe you stopped after just figuring out the first number that we needed to figure out. So that's this guy here, 1/10 of 5,000. If you stopped after that because you were in a hurry, you would get there, and you would be trapped and sad. So, choice D is the correct one. I think it's worthwhile to point out trap answers on the GMAT, both in the quantitative and in the verbal portion, because every once in a while, I mean, of course, if you're lucky, this will never happen to you on the quantitative side, where you have to do process of elimination. But on the verbal side, there are questions that flat out there is no other way to solve them than process of elimination. So it's always worthwhile to see how wrong answer choices are constructed. Okay, number 11, still last one on page 153. So our answer choices on the board. We have 0.004. We have 0.008. We have 0.02, 0.04, and 0.2. So, when you have decimal places like this, it's pretty clear there's going to be some sort of computation involved. So, which of the following is the value of the square root of the cube root of 0.000064? We'll write that up here. So, 0.000064. And we have the cube root of that and the square root of that. One of our first steps is going to be to remove the radical signs. As beautiful as they have been drawn by me on this screen, they really do make our life more difficult. The other thing we want to do is convert this unusually long for the GMAT decimal into something more manageable. One of the things to remember about exponents in general, exponents and roots, is that when you're dealing with things with the same base, so for example, if you have these square root of xy, that's the same thing as the square root of x times the square root of y. It makes your life a lot easier. We can do that same thing here by doing something that you also may not have done since high school, which is scientific notation. So 0.00064 is the same thing as 64 times 10 to the negative sixth. So 64 and then 6 decimal places to the left. And then this is ready-made for this format here. So we have, remember, this is the cube root. We'll leave the square root sign off for now, and then you'll see why later. So from there, that's the same thing as the cube root of 64, which should be nice for us, times the cube root of 10 to the negative sixth. Cube root of 64 is just 4. That's the main reason why we did that. And remember, the cube root is the same thing as the 1/3 power. So we have times, oh, I didn't want to do that. I wanted to do this. 10 to the negative sixth to the 1/3 power. Remember, when you raise exponents to exponents, you're multiplying them. So negative 6 times 1/3 is negative 2. So we have 4 times 10 to the negative 2 power, which is 0.04. Dun dun dun. But that's a trap. And we should be mad if we chose that answer choice. Because, remember, what we've done is just the cube root that's within the radical sign, the overall square root. So we actually need to find the square root of this number. So what we really still have to do is this. And once again, we can separate the two elements out. We have the square root of 4 times square root of 10 to the negative 2. That equals 2. And then it just ends up being 10 to the negative 1. I'm just going to save the exponent step, but it comes out to be the same thing. So 10 to the negative 1 is just 1/10. So we end up with, this is the same thing as 0.2. That is our correct answer. So a little bit tricky. I would characterize this type of skill with exponents and roots as absolutely mission critical to doing well on the GMAT. You really do have to be comfortable with exponents and roots, which are basically the same thing. Again, this is kind of our case in point in how you can switch from you can make roots into exponents and simplify your math quite a bit. So if you aren't comfortable with this, absolutely review it before test day. Actually, review it before you do too many more practice questions. This stuff is absolutely key. Okay, we're going to move on to the next page. That's about as big as I can make this eraser, so sorry it takes a little bit of time. All right, number 12 on page 154. We have A, B, C, D, and E. We have 2/5, we have 2/7. We have 33/83. We have 99/250, and 100/249. This one should be interesting. Raffle tickets numbered consecutively from 101 through 350 are placed in a box. What is the probability that a ticket selected at random will have a number with a hundreds digit of 2? So remember that probability equals the number of desired outcomes, where desired is kind of a euphemism. It's the number of things that are the thing you're trying to figure out. Remember that even when you're talking about things that you don't want to happen, like a raffle for a punch in the face, your probability is still the desired outcome, even though you don't really want to be punched in the face. So desired outcomes over the total number of outcomes. Probability is always expressed as a fraction between 0 and 1 inclusive, so something with a probability fraction of 1 is totally going to happen. Something with a probability of 0 is totally not going to happen. Somewhat intuitive, but it's worth mentioning. So in order to figure this out, we need these two numbers. We need the total outcomes and the desired outcomes. Let's do the total outcomes first. So raffle tickets numbered consecutively from 101 to 350. So if they were 1 to 350, there would be 350 total outcomes. But since they're 101, we subtract 100, there are 250. I guess another thing that's really important to this particular question and the GMAT in general is that you have to remember that, let's just say, how do I put this? The numbers 1 to 10 have 10 numbers in them. You'll see why I'm mentioning this in a second if you don't already. And so that's, you go through all 10 possible digits in the units digit, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. That's 10 digits, and so there are 10 digits from 1 to 10. We've gone from 1 to 0. When you go from 1 to 11, that's 11 numbers. The reason this is important is that's why this particular question has the raffle tickets going from 101 to 350, so that it comes out to be one of these even numbers. Okay, anyway, we'll come back to this because it's important. So we know that whatever the probability fraction is, it's going to be out of 250 because 101 to 350 gives us 250 possible outcomes. The number of desired outcomes are those with the hundreds digit of 2. So those are the ones from 200 to 299. This works the same way as the thing I was just talking about where we have the number of numbers. So going from 20 to 29 is going to be exactly it's going to be there's 100 from it'd be 10 from 20 to 29. It's 100 from 200 to 299. So this is 100 tickets in that range. Note that if we went from 200 to 300, that's actually 101 tickets. So this guy here goes here. So 100 out of 250 is this. You divide both sides by, or both the numerator and the denominator by 50. You come up with 2/5 as your correct answer. Why did I go to all that trouble to explain how many numbers there are in sets of numbers? Because 3 of these answer choices are traps based on assuming that you aren't able to figure this out. So, for example, if you think that there are 9, or if you think there are 249 249 numbers between 101 to 350, that's where this answer choice gets its denominator, 249. If you think there are 99 tickets from 200 to 299, that's where this one gets its numerator, its incorrect numerator. And then choice C is actually assuming that you think both of those, that you think that this one was originally 99 tickets in the 200 to 299 range over the 249 and the 101 minus 350. And so really these numbers come out from people subtracting 299 minus 200. Oh yeah, that equals 99 tickets. Or and they do 350 minus 101 equals 249. Don't do that. It works differently when you're actually counting the number of numbers rather than the difference between the two numbers. Anyway, choice A is the correct one. On to the next question. Okay. Number 13. So we have dollar signs in all of them. All right. So we have 1600, 1850, 2250, 2400, and 2750. Money. So when Leo imported a certain item, he paid a 7% import tax on the portion of the total value of the item in excess of $1,000. If the amount of the import tax that Leo paid was $87.50, what was the total value of the item? So again, converting words to math, 7% of the total value of the item in excess of 1,000. So we subtract 1,000 from the value of the item, that's the amount that it's in excess of 1,000, and 7% of that is the import tax that Leo paid. Converting that into math, so whatever the thing is, let's call it X minus 1,000. So that's the amount that it exceeds the $1,000 kind of minimum. 7% of that is what he paid, and that equals $87.50. What was the total value of the item? So here we're actually trying to solve for X. So you can do this a couple different ways. You can divide by 0.07, or you can multiply times 100 to move the decimal place over 2 in both cases, and then divide by 7. Either way, you end up with it ends up being so if you divide both sides, X ends up equaling 2,250. If you end up solving the whole equation, then the amount that it was over is 1,250. Whoa, I don't know where that number came from. Let's just get rid of that. So it was 1,250 over 1,000. Luckily, they didn't give us that as a wrong answer choice. And the total cost of the item was $2,250, which is choice C. None of these trap answers jump out at me as being an obvious logical mistake. I think they are counting on certain types of mathematical mistakes rather than mistakes in your approach in solving the problem. Well, your mileage may vary. You may see an obvious way to come up with these. Anyway, I don't. So we shall move on. On to number 14. I'm going to undo that. It's going to be hard to erase. There. All right, number 14. We have 13 and 1/3, 13 and 13/16, 15 and 1/2, 15 and 15/16, and then 16 and 1/2. So on Monday, a person mailed 8 packages weighing an average of 12 3/8 pounds, and on Tuesday 4 packages weighing an average of 14 1/4 pounds, or 1/4 pounds. What was the average weight in pounds of all the packages the person mailed on both days? I suddenly realized that one of these trap answers is probably the simple average of 12 3/8 and 14 1/4. You'll forgive me, I actually didn't do the math in advance to average the two together, but one of these is almost certainly that trap. The reason we can't do that is that with 8 packages sold, mailed at the one weight, and 4 packages sold at the other, the average of all 12 packages will not be the simple average of the 2 weights. This is what's called a weighted average, where we need. Oh, that sounds like I was making a terrible joke because we're talking about weights of packages. But no, all of these, when you have more of one kind of thing going into an average than some other kind of thing, and then it's being averaged together, that's called a weighted average because you're weighting it according to the representation of the different elements. So, remember that the formula for an average is the sum of the numbers that you're averaging together over the number of numbers. Weighted averages aren't different technically, but what you have to do is do some multiplication in order to get the sum of the numbers to come out to accurately reflect that weighting. So in this particular case, we have 8 packages. So we're doing the numerator of this fraction first. Well, we know the whole thing's going to be over 12 because there's 12 packages. But the numerator is the tricky part. So we know that there were 8 packages mailed at 12 3/8 pounds. And we also know that there were 4 packages mailed at 15 1/4. Now, if we wanted to, we could write out, 12 3/8 plus 12 3/8 plus 12 3/8 8 times, and also add that to 15 1/4 written out 4 times. Multiplying these is the same. Remember, multiplication is just a fast form of addition. So this is adding these two numbers together is the same as if we had written out all of these numbers individually. This one 8 times and this one 4 times. So these two added together is our sum divided by 12. The first thing we should do is get rid of these fractions and make them into improper ones. So this is going to be 8 times 12 plus 3 gives us 99 eighths. And now we can already recognize that we're going to have the denominator of the fractions canceled out by the number of packages that we multiplied, which is going to be nice because I wasn't really looking forward to doing all that. Whoops, I'll do that. 4 times 15 plus 1 is 61 fourths. Still over 12. But here once again we have these fractions that are going to be canceling out. So 8 times anything eighths, these go away. 4 times anything in fourths, these go away. So then we're left with 99 plus 61 over 2. 12. Oh my gosh, sorry. That's over 12. This is also over 12. So 99 plus 61 over 12, that equals 160 over 12. And when you divide that out, it comes out to be 13 and 1/3, which is choice A. Again, the key to this one, twofold. One, the most important thing clearly is recognizing that you have a weighted average and not a simple average. The other element is just recognizing that you could cancel these things out rather than multiplying 99 times 8 and then going and dividing by 8 and doing the same thing with the other fraction. Doing some canceling whenever you can is a key to GMAT speed. All right, we'll move on. On to number 15. Okay, number 15. Our friends, the letter answer choices. 0.1, 0.111, 0.1211, 0.2341, and 0.3. So 0.1 plus 0.1 squared plus 0.1 cubed equals what? So 0.1. So this one is just testing your ability to recognize how to raise decimals to exponents. It's important to remember that positive numbers less than 1 get smaller as the exponents get higher because you are doing fractions of fractions of fractions. The higher the exponent, the smaller it gets. This whole sum should be it will be larger than 0.1 because we are adding things to 0.1. So we can actually automatically just eliminate choice A. 0.1 plus anything that's not a negative number is going to be greater than 0.1. So choice A, I don't know why somebody would pick that, but don't do that. Next, we just need to compute what these individual things are. So 0.1 stays as 0.1. 0.1 squared, so just as 10 times 10 is 100, 1/10 times 1/10 is 1/100th, 0.01. You could also just multiply it out, either in your head or on paper. Just 1 times 1 stays 1, but then you have to move the decimal point over 1 because you have a decimal point in each of your multiplicands. So then cubed, we're just going to multiply this number times 0.01 one more time. A hundredth times a further tenth, just as 100 times 10, you get 1,000 or 1,000th, depending on which side of the decimal you're fighting on. So this ends up being 0.001. We need to add them together. So we have 0.001 added to 0.01 added to 0.1. You can add those zeros in to keep the place if we want. 1, 1, 1, 0. So clearly then, choice B is our happiness and MBA inducing answer. Right. So again, just being comfortable with recognizing how these numbers would work together, and that if you're ever in doubt, just actually multiply them out. It's very important. Yeah, that's it. Choice B, correct answer. On to number 16. Okay, so we have A, B, C, D, E. 20, 40, 60, 80, 100. So, a carpenter constructed a rectangular sandbox with a capacity of 10 cubic feet. If the carpenter were to make a similar sandbox twice as long, twice as wide, and twice as high as the first sandbox, what would be the capacity in cubic feet of the second sandbox? A couple different approaches that you can do here. You can just reason, basically, that if you are increasing each dimension by 2, that the final change in dimension will be, so if we're changing we have the length, the width, and the depth. Did they say depth? We say height. I'm not sure why we say height. Sandboxes are generally not tall, but we shall call it height. So if the length is times 2, the width is times 2, and the height is times 2, that's 2 times 2 times 2, which is 8 times more. So we take the 10 cubic feet from the original question, multiply times 8, and we get 80, which is the correct answer. You also could have picked numbers for this one, in case you weren't comfortable with that type of kind of more abstract thinking. So we know that the sandbox has a capacity of 10 cubic feet. We can also assume that because the answer, because we aren't given numbers, it's pretty clear from the way the question is formed that we will get the right answer no matter what numbers we pick, as long as the numbers we pick are right and work for the purposes of our question. So let's just say we have a sandbox that is 5 feet long, 2 feet wide. It's more of a sand strip, and 1 feet high. So this ends up being 5 times 2 times 1 equals 10 cubic feet. Anyway, so we need to double each of those dimensions. So we end up with 10 times 4 times 2. 10 times 4 is 40, times 2 equals 80. We arrive at the same answer by picking numbers. So whichever way you did this one is fine. It's no, I don't want to make sweeping generalizations. There are times when doing it the math way is clearly faster. There will be times when just picking numbers is as fast, and there are, of course, questions where picking numbers is the only way to answer it. So I don't want to, make oracular pronouncements about whether picking numbers is good or bad than doing the math or doing something more abstract thinking-wise. Anyway, in either case, both of them point to choice D. Okay, number 17. So we have 1, 2, 3, 4, and 5. Our question reads, a bakery opened yesterday with its daily supply of 40 dozen rolls. Half of the rolls were sold by noon, and 80% of the remaining rolls were sold between noon and closing time. How many dozen rolls had not been sold when the bakery closed yesterday? I don't know if you are the sort of person who does all sorts of math before you get all the way through the question. I don't generally recommend it, because this one could end up being a problem if you started to compute how many rolls are actually being done here. This bakery may as well be 1/12 its size and have all of these things not be in the dozen. It just doesn't make sense for a bakery to open with only 40 rolls in the store. So even though this is all with dozens, we can kind of ignore the word dozens for the sake of the problem, because all of the answer choices are likewise in dozens. You do need to be careful. It would be possible for a question to talk about dozens in the beginning, and you have to do the computation this way, and then the final answer could have been the actual number of rolls, because this one, all of these 1, 2, 3, 4, 5 are numbers that the GMAT could expect you to be able to multiply times 12. Anyway, so we just have to follow the question through, converting the words into math. We start out with 40 dozen rolls. Forgive me for not writing dozen. Half of the rolls were sold by noon, so that we just divide that or multiply it times 1/2. By the afternoon, we are down to 20 dozen rolls, and 80% of the remaining rolls were sold between noon and closing time. So 80%, so 20 is times 0.8, or 20 times 8/10, or if you like reducing your fractions, 20 times 4/5. In either case, no matter how you like to compute it, it all comes out to be 16. Luckily, the GMAT has not seen fit to give us 16 as one of the trap answers because some people would choose that. We're looking for the difference between the number sold in the afternoon and the total that were actually available in the afternoon. We're looking for how many are left. So there were 20 left at this point. 80% of those were sold. 20 minus 16 equals 4. Answer choice D. I don't really have anything to say about trap answers on this one. I don't really think there are any on this one. Anyway, okay, let's move on to number 18. Okay, number 18. Okay, so if the area of a square region having sides of length 6 centimeters is equal to the area of a rectangular region having width 2.5 centimeters, then the length of the rectangle in centimeters is what? So keep in mind that all squares are actually rectangles, and they're all quadrilaterals. So really the area is always the same. So the area of a rectangle is the length times the width. We know that the area of the square, the length and the width are the same. That's how we define a square. They have equal opposite sides. So we know that the area of the one with sides of 6, length times width, 6 centimeters each, that equals this other one with a, we know that its width is 2.5, but we don't know its length. So length times 2.5 centimeters, these two have equal areas. So then we multiply these things out. 6 times 6 is 36 equals 2.5 L. And then really it just becomes a division problem. So we have 36 divided by 2.5. I have to move the decimal place over 1. So 25 and 4. So it equals 14.4. Now, of course, if we were confident of our long division, we could have stopped as soon as we got the 14. There are no other answer choices that begin with that. But that final digit does function as a check digit in a way. If this came out to be some other answer, we would have to worry. Probably not so much on this problem, but on a more complex GMAT problem, we probably would need to worry that we had somehow miscomputed something earlier in the passage, earlier in the question. So if you're doing well on time, it's worth it to divide it out, just to make sure that you haven't gone too far down a false road. Anyway, 14.4 is the other dimension, the width of the rectangular region. Yeah, no obvious trap answers on this one to me, but your mileage may vary. I think we have time for one more. So we'll move on to question 9. Well, depending on how fast this one goes, we may have time for 2 more. Oops, next page. So page 155, question 19. %, 20%, 50%, 200%, 500%. Okay, so 150 is what percent of 30? This is another one of these convert to math. And this one, of course, the sentence structure makes this one really a little bit trickier. So 150 is the same thing as the equal sign. It's the grammatical equivalent of saying something is something else. So 150 is what percent of 30? So it's some fraction over 100, that's what percent means, of 30. And now this is a much more straightforward algebra problem. We can divide both sides by 30. And so in this particular case, x over 100 equals 5. This will end up being x equals 5 out of 100. So anyway, in this case, clearly the percentage here, x is 5%. Oh, excuse me, 500%. Sorry, yeah, there was the trap answer right there. We get that equals 5. Extra sad because I actually said that for a moment. Anyway, x equals 500. So it's actually this one. And, you know, our own common sense would have told us that that couldn't be right. 150 is bigger than 30. So any number less than 100% couldn't possibly be right, because when any percent larger than the original number must be larger than 100%. So these are all to other extents trap answers. But oh, and I suppose 50 would have been the other one if you did the math wrong. Well, I don't want to make it look like the correct answer. 500%, choice E is the correct one. I think I have time for one more since I got off to a slightly late start. All of our broadcasts need to be within the hour because we have multiple programs going on, and it would not do to be late. All right, question number 20. Last one that we'll do today on page 155. And you'll forgive me for writing these in shorthand form. Choice A is the ratio of 6 to 1. You can expect to see some ratios expressed that way, or know that it's at least possible. 5 to 1, 3 to 2, 2 to 3, and 1 to 6. So the ratio of 2 to 1/3 is equal to the ratio what? So remember that ratios can also be expressed as fractions. So the ratio of 2 to 1/3 equals. So one of the things we can do is simplify the fraction. Since all of these have, none of the answer choices here have any fractions in either part of the proportion. So we basically need to get rid of the fraction. So to get rid of fractions in the denominator, we can simply multiply times the same number in the numerator and the denominator. Remember that any number over itself, x over x, no matter what x is, equals 1. So multiplying by the same number in the numerator and the denominator is not actually changing the value of 2 over 1/3. It's just changing the way it looks. We multiply across the top when we're multiplying fractions. 2 times 3 is 6. 3 times 1/3 equals 1. So this is the same as the ratio as 6 over 1, which is the same as the ratio 6 to 1. Answer choice A. The other answer choices count on you to make some other errors in the computation. Obviously, this guy here, 1 to 6, is the biggest trap answer because you could do the math more or less correctly and still get the wrong answer that way if you somehow inverted the fraction. The other ones are counting on you to do other types of computation errors, or doing something with your weird cross multiplying, or basically doing it wrong in some way, as opposed to just being wrong numbers picked out of the air to attract guessers. In any case, choice A is the correct one. So we finished up, we got through question number 20. Next time we will start with question 21. You've been watching Grockit OGTV GMAT edition. We're going through the 12th edition of the official guide to the test cover to cover. My name is Jim Jacobs.